Bugünün ilk sunumu Sayın Ali Yapıcıoğlu tarafından. Kendisini sunumunu yapmak üzere sahneye davet ediyorum.
Günaydın, good morning. A change in the schedule. So yesterday there was a lot of great talks about how we deal with sustainability in different fields, and we heard from rural development, technology, to pushing boundaries in electronics and energy. Today I'm going to talk a little bit about how we deal with that in architecture. Architecture is a very wide range discipline that you have to talk and think about all of these aspects that we talked about yesterday and today. So I'm going to just mention materials, how materials could affect the architecture in sustainable manner. I should say a couple of words about myself. I'm a Cypriot, Turkish Cypriot, but I studied and practiced in U.S. Since 1989, and now I'm visiting Cyprus back and forth, and still practicing in U.S. So we all heard about how sustainability affects us, and I'm not going to go through all of them, but I'm just going to jump through the architecture, and since we talked about all the aspects yesterday. So when we do architecture, or when we design, or we think about a project, or a site, or a building, we have to think about environment. And by environment, it's just not the building side, that it's square or rectangle or round or whatever shape that might be. We have to think about beyond those perimeters. And what I mean by beyond, it is a street next to the project site, then the community, then the city, then the country, and then finally the globe. The foremost goal is to minimize the carbon dioxide expenditure, and doing so we can start to think about how we can actually design before anything else. To do that, then we go into materials. So we have to use materials. Whatever that material be, we have to use it. It could be material from local, it could be material from imported, it could be material from right on the site, but we have to use something to build with. Otherwise we cannot build. So we cannot ignore the materiality of the architecture. That's one of the big equation in the whole sustainability. And then today I'm going to talk about that. And we have to think about how we can find resources in a more efficient way in order to make this architecture or the environmental impact. And if we have to reduce the energy use when we design. It's not just the engineers and policymakers, but our architects have to be a big part of this reduction in energy use. How many architects in the house? Oh, there's one. I'm very disappointed in our chamber of architects. Then we have to think about how we connect our architecture to the rest of the globe. It's not just having windows and looking outside the street or the garden or to the beautiful view of the ocean. It's just how we look at how we relate to the rest of the world with the architecture we do or the engineering that we do. Then we have to think about with that, I wrote there urban and suburban context, but I just wanted to emphasize that we need to actually look beyond that. And then we humans do breathe. Our skins have cells, and any indoor quality will affect us. Any dust, any glue that we use to put the carpet down, the fumes from those affect how we live healthy. So that is architect's responsibility or engineer's responsibility, all the product responsibility to give us a healthy indoor environment. If we have a healthy indoor environment, I'm 100% sure that we're going to have less pharmaceutical in the world. Okay, Then I will jump right into, we talk about green architecture. It's in the quotation mark because I think the green architecture today is used very loosely. And the word green actually doesn't mean a lot of things. But since everybody's using the green architecture, then we have to use it as part of the industry's in that standards. Any architects can call their architecture green architecture, but what does that mean? Architect can tell you that I designed this building that it looks towards the ocean, that's why it's green. I'm just exaggerating, but it's not that. The green architecture should actually start from the site and then move towards the global scale. Green architecture is not equal to sustainable architecture. Sustainability is totally different than green architecture. Architecture by itself cannot be sustainable building. It has to tap into the community. It has to tap into the globe to become a sustainable building. So let's talk about materials. Now that I gave you a context of how the architecture in sustainability will work, I just wanted to talk about some projects that I designed and built, and then we will talk about these local materials, what they mean, and I myself seen using local materials that actually equals more jobs in that context. And actually, it is a more sustainable economy. And actually, it is a better living standard for the people that in that community. And it's actually, when you use local materials, you talk about this word. I broke mine, but mine is not working either. Embodied energy. Embodied energy, it's a big word, and it's a very important word in architecture and sustainability. What that means that this remote control, where it was produced, and from that point to that arrived to the desk, how much energy it is spent, including from the plastic, from the gas, from the airplane, from custom fees, everything. So that is the embodied energy of this remote control. So if I have to design this and build this in Cyprus, let's say in Lefkoşa, and it arrives here to this desk from 20 kilometers away, imagine the embodied energy of this, and imagine that if this was built in Singapore and arrived here, how much energy that you spent to have this here. So that goes well with the materials in architecture. And imported materials, and these are less jobs for local economy, and it is not actually adding any jobs or any helping any us in sustainable economies. And because the people that produce this, they live in some other part of the world, and we use it here, those people and us have nothing to do with us. So we don't actually gain from their product. So that equals to worse standard living, and it has a high embodied energy. So I'm going to talk about 3 projects, 3 continents, and a building material suggestion for Cyprus. So the first project in Madagascar rainforest, I'm going to talk about education and job opportunities on that project in architecture. And Cyprus, an urban project, and the North America rural project. And those are the main points of each project that I'm going to talk on these. So when we measure green architecture, who are to say that your building is green or your building is not green? And how do you measure this? And there are a lot of entities, but these are some of them. There are more. I'm just putting some of these out there. And leadership in energy and environmental design is the USGBC entity, is an NGO, and the BREEAM is mostly in Europe. And USGBC, United States Green Building Council, has a lot of rules and regulations and how to go about these listing and points. Passive House is started in Germany, and now it's spreading throughout the world. AIA 2030 Challenge, I think Halil mentioned that yesterday, and our office in US is actually committed to that challenge. We signed a agreement with the American Institute of Architects that we will work towards that challenge, and we're working towards that challenge. And you're conscious. You have to think about how you're going to design and how we can sustainable. And of course, more and more. So, what does sustain actually mean in a dictionary? Sustain is to keep in existence and maintain. So if we can keep in existence and maintain a building with the material that we use, so we don't have to, if this light bulb is out right now, we may have to wait 2 weeks in order to replace it because it's going to come from Scandinavia, it's going to come from China. But if this light bulb was produced here, I can go and get it from the store and then replace it right away. So what does that do to our sustainable meaning? You have the right away. If this light was out yesterday, I was going to be without a light in order to change it. Again, I'm exaggerating this a little bit, but to make my point. So this is a monastery in Kyrenia Mountains. And the reason I'm using this, I'm going to refer to this picture one more time. And you see how the monastery and the mountain is almost they're just melted together. It's like you can feel that the monastery was built out of this mountain. And you can see the detail of the stone wall that this monastery was built. So when you look at this, and look at this, they're just one body. So, in the same monastery, you have the ceiling construction. And the ceiling construction, there's a construction technique that vernacularly used in Cyprus. Basically, these are the beams. They are either from the area, most likely they're cypress trees, and the reeds above them, and the mud kiln mix on top of it. So, if they didn't have this reed next to this project, and the clay next to the project, because the clay dries during the summer, and you have to put another layer of clay on top of it in order to maintain it. So if that roof was a aluminum clad roof, how are they going to maintain it if something happened to aluminum? You have to go to China to get it, or you have to order it from China. But the clay is right there. You dig the clay, you mix it with water, you apply another coat on the roof, and voila, you have another roof for another season. I'm going to come back to that slide. So the first project is in, it's a research center, education center in the island of Madagascar, southeast of Africa, in the southeast rainforest of the island. So as an architect, you go to a place, you get inspiration, you do research, and then you start thinking about your project. So this village was our inspiration for the floor plan, how the locals live, and how we can propose something that they feel comfortable, that when they go in there, they feel like they're in their village. And then you go through all your research and construction techniques, how they use their local materials, and how can I learn from this? The city, rural, and then you come up with a plan thinking there's inspiration, and then this inspiration, you see the little squares and pots like little village, and in the middle, it's the plaza of the village. That's how the Malagasy people actually form their villages, and it's not different than any other villages around the world. There's always a plaza. We always look into the plaza. And then you start thinking about how I can work with a current creek water feature that I can turn into a more sustainable way of locals to use it instead of constantly draining into the river. So what we propose is and this doesn't look right, the little red thing. So we propose a eco-swale. The red line is how it was before, and the swales are what we're proposing. So what are we proposing there is to create a little pond that they can actually do fish farming. Otherwise, this river is going to go and drain into the larger river, and all the fish that comes from upstream will go to the bigger stream. And then we start thinking about how we can make this building to breathe, to have a daylight, so we don't have to turn the lights on till it's dark. We don't have to turn air conditioning on. We don't have to have heating on till we actually need it. And these are all from the beginning of the buildings. We society or people, we used to build things with the local material. Why most of the caves opening do look to the east? Why we build with the local materials? These are all people that learn from their conditions and they built to that. If I build my caves opening to the west and then in the morning sun's going to rise and I still think that it's a nighttime. So sun comes up, it goes into the cave and then I wake up. So there are architects here, they probably study this in architectural history, but these are very simple things that we're actually forgetting about right now, and we're now going back and researching that, saying that these were sustainable way of living. Let's go back and learn from these. It's very interesting. And then how do you actually collect water? It's a rainforest, so there's a lot of water. So what do we do with this water? We, of course, collect it. You're not going to have the building to drain into the river. So we collect it and we treat it. And all of the toilets in this building is used gray water from the rainwater. Then they are collected through the green roofs. So green roofs keep the building cooler, and then slowly gave into the cistern system. So what else we can learn from the local culture? Madagascar is one of the cultures that use a lot of rice. It's probably per capita, it's third or fourth in the world. So they have a lot of rice paddies. Rice paddies in the upper right corner, they plant twice a year. The yield is twice a year. So what they do, every time they replant it, you see those mud, excess mud, and what they do, they rake that mud and they turn into bricks. So beyond is the rice paddies, and these are the brick kilns, and they burn them, and then you have a local brick. Another example of the brick kiln is burning. So this is a village next to the project site. Madagascar is a geological island, so there's a lot of granite. And so we choose two materials, granite and brick. And the granite comes in a lot of different forms. And this lady is actually breaking gravel for our building. About 10 villages broke gravel for concrete for our building for 6 years. There's no machines, there's no concrete plants, everything is done by hand. And the sand was dredged from the rivers, and then the building is, actually all the concrete was built that way, and mixing it by hand, of course. So that way, that material, and this lady, you see the house behind it. When I went there 3 years ago, that house was plaster, it was new windows, everything was looking great, and upper part of the village, there was a little pension, there was just a hostel, and the 6 years that we were there, it made the local economy grow exponentially. The granite, use of granite in the local zoo. So we kind of said we'd like to use that granite to our building, and we did a lot of mock-ups. There's a lot of bamboo in Madagascar. We used bamboo in our ceilings. And then we did interpret their local materials to with the innovation of new technologies. And then, so they're used to do the bricks, double or triple white, and then they set them on the ground. Of course, it rains. Every time it rains, that water just sucks up to the wall, and then crumbles at the bottom. So we introduced them the cavity wall, using their brick, but showing them how to do the cavity wall, and how to deal with the, how to join the plaster with the granite and brick, and then they use the materials that way. We also engaged the Women's Co-op to do all our tabletops and all the window treatments. And they did this, and they're silk and cotton. And they're beautiful, beautiful garments. I have many scarves for my wife and myself, and there's a lot of great designs. And then we built the building right at the bottom of the river in the rainforest. And we try to engage the rainforest with the building itself, and you will see the granite and the brick materials. The locals call this Titanic. And one of the things that when we first went there, the University of Stony Brook in New York is the major donator for this building. It's a research and education center. They told us that we have to educate local craftspeople. So they learn how to do plumbing, they learn how to do masonry, they learn how to do electrical. And the big part of this, we went there and we did a lot of workshops. And now those people that work there with no skills, right now they're plumbers, electricians. They don't have to go to capital city in order to make money. They can stay there. Since the economy is growing, there's a beautiful rainforest national park next to this project. And lemurs are extinct animals, and there's only in Madagascar and in Puerto Rico. So a lot of tourists comes here for bird watching, and lemurs. There were existing buildings, and this was a rice paddy, and you see the skylight at the top that has a moisture-built sensor that opens up and the moisture goes up. Use of brick in different ways. We use the granite as a paver, we use the granite on the walls. And how do you connect with the existing building on site? What is the connection? An interior using bamboo, flooring. Then when we did scaffolding for this building, they're really famous for doing all the bamboo and eucalyptus formwork. So part of the municipality is building fee. We agreed to build them a marketplace in their downtown. So all the materials from the building, scaffolding, went to build this marketplace as part of the taxes, basically. And this is their marketplace right now, and there are different stalls, and they sell their local garments. The second project is in rural America, in state of New York. The owner had barn buildings, and they were about to collapse. And they told us, we want to build a small building, zero net energy, and we have these barns. Can you go and take a look at it if we can use them? So we went and measured every single beam and designed a house for them using all those measurements. And this house actually received a LEED Platinum certificate from the USGBC. So again, as architects, we like to see how we can make this house so we can have it a zero net energy. The energy consumption is the utmost equation here. So this house has PVs and geothermal system. And of course, the passive systems as well, the sunshades and concrete floors and very high insulated value. The house is used only those materials from the barns. And this high area is where we bury the house in and put all the geothermal system underneath, so we can get the geothermal advantages. Again, the use of the barn wood, and we didn't put any paint on it. It will age, and it aged, and it's aging, and it's becoming beautiful. As I get gray hair, this building is getting grayer as well. So it's a natural thing. Buildings they are living entities. So we have to recognize that. It's not a brick and mortar, as Americans say. It's a very, very small house. It's a one-bedroom house. And a garage that is actually larger than the house because he had a lot of toys. And the beams all are from the building as well. And the third project is in Cyprus, in Girne. We're still working on the project, so I don't have the final pictures, but I'll show you some of the pictures that we have it. Again, I'm not going to go through the analysis, what we do and how we make it, what kind of system we can use before we start the project. You have to think about all these systems before you start the project, not while you're construction. It has to be planned. And how do you connect to the rest of the street? Can you do more green and you don't touch the existing fauna or the trees? These trees, all the trees that you see here and there, and the shape of the building is because they are existing trees. And you just work with the plan. And the building, actually, I was inspired by colonial architecture in Cyprus. And then most of you are from the Cyprus, so you will know the courthouse in Lefkoşa, courthouse in Girne, courthouse in Mausa. They all done by British colonial architecture, and they all have larger balconies, terraces, that people actually go out there and socializes. So the idea for this building came from the social ideas for this building came that area. And then there is a courtyard in the building right there, and the stairs that actually acts as a social entity of the project. We Cypriots love to have coffee and talk. So we have to provide them and smoke. So we have to provide them some of the benefits of that. You cannot ignore it. If you live in a culture and you're an architect, you have to know about your culture. You have to give them what they think that it will be the best. And then again, the courtyard is an important part of this project. And local materials. All the flooring for the entire building, which is 10,300 square meters, and the plaza, the floors are done by the local gravel. And we introduced this exposed aggregate, and then we did concrete floors using all the local aggregate with the insulation below them, and we did all polish. We did raised floors using the local manufacturer panels. And then innovation, and then I inserted that little picture on the right hand corner to show you that how it was used 300 years ago with the mortar, and how you can use the same stone in 21st century with the innovation and interpretation. This stone is the same stone as that. This gray stone is the same stone as that. In this project, I used that stone in 3 different forms. I finished it with a polish, I honed it, and I left it rough. And the building because of the system, it's a rain stream detail. Because of the system now, the pressure from outside to inside, this is an equalizer of the pressure from outside to inside. What happens in Cyprus that most of the houses, they're brick and mortar. And when rains hit the brick and mortar, because of the inside atmosphere is lower than outside, and there is a constant travel towards inside. But if you balance it and equalize it, it doesn't travel. So this actually does that. So no rain will travel into the building. It will stop right there. The same stone used on the stairs and the wall cladding, it's polished this time. Seats, wall, and the yellow stone is, the gray stone is buafento, yellow stone is kumyala. And it is sliced in small, thin pieces. We use the integrated solar photovoltaics as a vertical application. They have a 30% of transparency that let the light in a little bit, but it also generates electricity, the black windows. Those are the existing trees that we built around them. And then the inspiration of the courthouses is those stairs. They're sculptural. One goes on top of this way, one goes here. So when you're here, you look down and you talk to somebody that actually on this element. Right? So they're not on top of each other like traditional stairs. And on top of it, we, in order to do some sunshade and the rain shelter, we built this, and we also use the integrated photovoltaics for this as well. And we use some color. When the sun hits those red or yellows and it hits the ground, you'll have a Mondrian effect of different colors. And that's the stairs looking up, taking the photograph looking up this way, then on the right. And you see the shell on this side of the building. And all the roofs are planted roofs. And this is the courtyard that people will hang out and have coffee and smoke cigarettes and chat. And we clad the entire building in this local material. Imagine how much work that we created doing this material instead of bringing aluminum cladding from China, let's say. And then the building actually sat in two heights. One is lower than the other one in order to bring the winter sun in. But in the summer, these offices, they all have a shade structure that you can close and open and then regulate the sun. I did a temperature measurement from outside and inside, and there's about 8 degrees difference when they are closed. And then my suggestion for I'm going really fast. I know I ran out of time. So this is a building technology or a construction system that I think if Chamber of Civil Engineers, Chamber of Architects, Chamber of all the engineers think about this, and we use this material to build 2-story, 3-story buildings. Right now, we're digging basements, and we're taking the earth, I don't know where. They're going somewhere, but nobody knows. In the sea, in the riverbeds, landfills. So you use actually a lot of sand and gravel. If you do non-stabilized system, which has no cement, and you can do stabilized system, which has by volume, by mass, only 6 to 8% cement. Then the material is here. Then you don't have to use any energy. And you can build walls, the rainbow effect like this. And I did a lot of workshops on this, and I did some projects for the municipality using this project, and we found 3 different colors, earth from different regions of the Cyprus, and we sieved them, we mixed them, we used the formwork that Cypriot contractors are very familiar with the formwork because of concrete, and we just detail these walls that way. You just put the earth in it. It's not a mix with a lot of water, just a little bit water, so you can compact it to 99% compaction. And then you can detail it, do some architectural details. And these are the walls for the Kyrenia municipality's recreation area. So instead of doing all steel or all some other materials, that we actually designed the concrete benches and trash cans and such for this little project. And then you can do a project like this. Thank you. Questions or later? Yes.
So for the Madagascar project
Yes.
that you've involved in, so for clarification, did you use concrete for structural elements?
Yes. It's a cyclone region. There's about 100 and
They asked me to re-ask the
Okay.
question. Would
Okay.
you let me? Okay, my question was for the Madagascar project. And I asked, did you use concrete for structural elements?
yes, we did. The Madagascar is in the cyclone region, so we had to use a concrete structure in order to retain for that forces, wind forces. There are about 110 kilometers of hour winds that come through the rainforest. So the structural is a concrete.
Yeah, I do understand. Yet, may I ask, what was the local material that they were using in the past for structural elements, for ceiling, for... They were not building columns for sure, but for beams maybe.
They used plaster, stucco.
Okay. Thank you so much.
Yes, it was a really nice presentation. Thank you very much. Actually, I picked up on the same point that we were discussing, because cement, where Halil Güven Hocam was talking yesterday, that's the most how do you say, CO2 emission producing element, and we're trying to reduce that actually. As I'm a geotechnical engineer as well. And we're trying to find the ways of adding some other materials as a replacement. So actually there is some ways of increasing the durability. As you said, Madagascar in a region that you might need to use the cement, but there would be some ways to use additives, not additives like natural additives. For instance, in Cyprus, we did the research on tamped earth, when I was in Lefke University, and we used copper slugs as a replacing material to your cement. Like I see that there was 6 to 10% of cement for the tamped earth.
By volume.
By volume. There is a reduction of that down to 2%, 3% cements by using this, how do you say, remain material, like which is in, Lefke. It's
Yes.
It's a leftover of copper mine. So actually there is some ways in that sense that we can do this in Cyprus, which I really enjoyed to see the RAM Earth project actually.
You could actually do a ram earth without any cement. It's a non-stabilized application,
Yeah.
but therefore more for an interior.
Yeah, and durability-wise, it would
of
have
course,
some
yes.
effect later
Yes.
on.
Yeah.
Okay, thank you very much. Thank you.
Any other questions?
Not a question, but congratulations.
Thank you.
Really, particularly the one in Cyprus is unbelievable. It's the first one of the kind, right?
Yes, and it is a LEED certifiable. The Kyrenia Municipality building is a LEED certifiable. I'm hoping that I did a preliminary to silver, but the council is not giving me $65,000 to get the certificate. It is, I mean, everything is ready. I did all the preparation work. I just need to submit it to LEED, and I need $65,000.
Ways of fun.
Thank you.